Hello friends, today I'm going to discuss the LCR circuit and complex number. Uh, to actually analyze the LCR circuit in case of AC source, you need to apply the complex number. So first of all, I will provide a simple introduction to the complex number. Then we discuss how to analyze the LCR circuit. Now, the complex number is generally represented by a term z. Z is simply x plus iy. Here, x represent the real number, a real part, and y is the imaginary one. So, and you can represent it by I or j. J is actually root of power of minus of 1, this is the complex number. So, in a graphical presentation, we have two axes. One is x-axis, the real axis, and this is jy. This is plus jy, and this is minus of jy. So this is the complex plane, and in any point x comma I jy, that is represented by a line, and this angle is theta. So the amplitude of the complex number is given by mod z, and this is equal to x square plus or y square, and theta angle is given by tan inverse of y by x. So these are the things. So now if you put x equal to r cos theta and y is equal to r sin theta, then z is equal to r of cos theta plus of j r sin theta. Then if you take common r, this will become cos theta j of sin theta, and this can be written as r to the power j of theta. This representation is called the Euler form. Okay, and in case of a LCR circuit, sometimes we need to add the resistance or impedance or subtract it. So in that case, Cartesian form is valuable. And when we multiply and divide the impedance or reactance, the polar form is important. So from sometimes we have Cartesian form, from there to we can convert it to the polar form and vice versa. So let's analyze some simple circuit. Say this is a resistance and this is inductance and there is a capacitance, and it is governed by a AC voltage source, and this is R, this is L, and this is C. So here the impedance Z is written as R plus of J omega L plus of 1 by J omega C. So if you take common J, then this will become omega L by 1 by omega C. So if you take the modulus here, the mod Z, this will be equal to R square, R square, R square, and omega L minus 1 by omega C square. And theta is very simple. Theta is tan inverse of omega L minus of by 1 by omega C divided by. Okay. So in polar form, we just find out the mod of Z value and theta. Now we take an example here so that we can easily understand. the how to analyze the LCR circuit. Suppose say this is a resistance and there is an inductance, another inductance and resistance here. Okay, it is connected to a AC source. Let's say this is a 200 volt and 50 hertz. Now, for sake of simplicity, suppose say this is 20 ohm resistance, this is a 30 ohm inductance, and this is 30 ohm inductance and 20 ohm resistance. Okay, so we have two impedance, Z1 and Z2. Suppose say this is Z1 and this is Z2, and these two impedance are in parallel. So first of all, we just want to calculate Z1. Z1 will be equal to 20 plus of J30. Okay, and J2 is simply 30 plus of J20. So these two are the Cartesian form, and we can actually convert it into the polar form. So for the first case, for Z1, the mod of Z1 is simply 20 square plus of 30 square. Okay, and 20 square and 30 square, we can calculate from here. 20 square, 20 square plus 30 square. And this is 900. Okay. So, so this is 400 plus of 900. So this is 1300. So we need a scientific calculator here. So square root of square root of 1300 is equal to 36.05. So this will be equal to 36.05, and theta, that is theta 1, is equal to tan inverse of 30 by 20, that is 1.5. So we need a calculator here. So tan inverse, a trigonometric function we need. So arc tan inverse of 1.5. So 1.5 here. So this will be equal to 56.3. So this is actually 56.3. All right. So in polar form, here Z1 can be written as like 36.05 and with the angle of 56.3. Okay. Similarly for Z2 here, so Z2 is simply again 30 square plus 20 square. So again, it's count like 30.05. And here we need to calculate again because here theta 2 is simply like tan inverse of um, 20 by 30. Okay. So the again 20 by 30 divided by 3, which is equal to 6.6, and second inverse trigonometric function 10. So this comes around 11.23. So theta 2 here simply 11.23. Okay. So here this is 11.23. Now Now we have calculated the Z1 and Z2 here. Now Z1 and Z2 are parallel, so the total impedance Z total can be calculated using the formula Z1 into Z2 divided by Z1 plus of Z2. So here is multiplication. In case of multiplication, only thing is that Z1 and Z2 just multiply Z1 and Z2. This is 30.05 into 30.05, 36.05, and the angle will add up. That means 56.3 and 11.23. So this will become 67.53. Okay. And for addition, as a we have said, for addition, the partition coordinate is much more valuable because if you just add Z1 and Z2, then real part will add up. So it become 50. And then here also 20 plus 30 is 50. So it become J plus J into 50. And now if you take the mod of Z1 plus of Z2, then it becomes 50 square plus 50 square. Okay. And root. So it becomes 50 root 2. And the theta is simply tan inverse 1 because 50 by 50 is 1. So only 45 degree. Okay. So here the presentation will be simply like 50 root 2 and angle at an angle of 45 degree. Now again it is divided. So polar form is suitable here. So first of all you just multiply 36.05 into 36.05 0.05, and then we divide it by 50. So divide it by 50 and then divide it by root 2. Root 2 is 1.41. So simply 1.41. So we'll get what we will get. We will get 18.43. So here I'm getting 18.43. Okay. And this will, these two angle will, we need to subtract it. So this is 2 and this is 2 on 5.3. So total, that is the jet total, comes around 18.43 magnitude, and the angle is simply 22.53. Okay. Now, if you want to find out the current here, so current is simply like V by jet total, and jet V is here simply 200, and jet total is 18.43. Okay. And again it is 0, and this is equal to 22.53 degree. So just take a divide from 200 by 18.200 divided by 18.43. So 200 divided by 18.43, and this is simply like 10.85. So current is 10.85, and it is lagging 22.53 degree because 0 minus 22.53 is 9. So in this way, you can actually analyze the LCR circuit. Okay. And you can also draw the phasor diagram here. So in some cases, the Cartesian coordinate is very helpful, and in some cases, the polar coordinate is very helpful. So I think this will help you to find out the uh, or find out or any problem solving case. So keep watching, and thank you for your patience, and please subscribe. Thank you.